Earthquakes are a powerful and often devastating natural phenomenon that result from the dynamic processes at work within the Earth's crust. At the heart of the science behind earthquake formation and behavior are the theories of plate tectonics and elastic rebound. The Earth's outer shell, the lithosphere, is divided into several large and numerous smaller pieces called tectonic plates. These plates are constantly in motion, drifting at a rate of a few centimeters per year, comparable to the speed at which human fingernails grow. Their movement is driven by the intense heat from the Earth's core that causes convection currents in the plastic-like asthenosphere beneath the plates. Most earthquakes occur along the boundaries of these tectonic plates. There are three main types of plate boundaries: divergent, where plates move apart; convergent, where one plate dives under another; and transform, where plates slide past each other horizontally. Earthquakes can happen at all these types of boundaries, but the mechanisms that lead to quakes vary with each. In a transform boundary, the plates slide past each other and friction causes them to stick together. Over time, stress builds up at the fault line, the crack that marks the boundary between the two tectonic plates. According to the elastic rebound theory, when the stress exceeds the strength of the rocks, the plates suddenly slip, releasing energy in waves that radiate out from the fault. This sudden release of energy is what causes the ground to shake. Divergent and convergent boundaries similarly experience earthquakes when the tectonic movements cause stress that exceeds the rock strength. The energy released by an earthquake travels in waves, and there are several types. The primary waves, P waves, are compressional, moving through the earth quickly, while the secondary waves, S waves, are transverse and can only move through solids. When P and S waves reach the Earth's surface, they create long wavelength surface waves, which are typically responsible for the damage caused by earthquakes. The magnitude of an earthquake is a number that characterizes the energy released. It is commonly measured using the Richter scale, with each whole number increase representing a tenfold increase in measured amplitude and approximately 31.6 times more energy release. For large events, the moment magnitude scale is a more accurate measure of an earthquake's size. Beyond the magnitude of an earthquake, its destructiveness is also influenced by the depth at which it occurs, the distance from the epicenter to populated areas, the local building standards, and the geological conditions that may amplify or dampen the seismic waves. The study of earthquakes and their propagation is important in several aspects, such as hazard assessment, engineering, and city planning. Although scientists have made tremendous progress in understanding the science behind earthquakes, predicting the exact timing and location of these events remains a challenge. Nonetheless, through seismology, the study of earthquakes, researchers are developing tools and methods to help societies around the world prepare for and mitigate the impact of this natural phenomenon.